Okay, this is going to be the fourth video in our series on word problems, and in keeping in the spirit of things, since it's the fourth video, it's going to be a 4-variable word problem. Family gets mail. This is a nice problem. We're going to read the problem a couple times, try to make sure we understand what's going on. We're going to come up with variables to represent everything we don't know, and then because if there's one variable, you need one equation. Two variables, you need two equations. Since this is a 4-variable problem, we're going to need to come up with 4 equations. Okay, this is a simple problem. We're just going to read it. It says, on March 16th, the Moore family received 31 pieces of mail consisting of letters, bills, magazines, and ads. If they received 3 more bills than magazines and 5 more ads than bills and the same number of letters as magazines, how many letters did they receive? One of the nice things that the English department does is they put these little question symbols in there at the end of a sentence where the question is actually being asked. It looks like they're saying, how many letters did they receive? So I definitely want one variable, maybe L, to represent letters. But if I read the thing, I realize that there's letters, bills, magazines, and ads. There's several things I don't know. And then they kind of talk about the things and the fact that they got 3 more bills than magazines, 5 more ads than bills, and the same number of letters as magazines. So if I knew how many letters I got, I'd know how many magazines I was getting. If I knew how many bills I have, since there's 3 more bills than magazines, well then I'd take the magazines, whatever that number is, and add 3 to it. So I know how these things relate to each other. I just want to start coming up with some kind of a equation system to explain this. Okay, so we're looking at the problem, and there's clearly 4 variables. There's letters, bills, magazines, and ads. And I'm going to use letters that I think make sense. So L for letters, B for bills, magazines, M, and A for ads. The next thing I'd like to do is, if possible, draw some kind of a picture that might help me understand what's going on. They got a stack of mail consisting of letters, bills, magazines, and ads. So I'm going to draw a little stack of letters. And I don't have to be an artist, they just need to look kind of like a rectangle. The bills, well, it looks like a letter, but it has money related to it, so I put a little dollar symbol in there. Magazines are, again, kind of a rectangle, but they're different shaped rectangle, and I could think of Sports Illustrated, but in this case it's Time, some phase on it. Ads, well, ads are just kind of like a rectangle, you know, but usually it says something like 50% off, or, you know, that there's some kind of a sale somewhere so that I can take advantage of. At this point, because I don't know much better, I made all the stacks look the same. However, if I read up here, it says that there was 3 more bills than magazines and 5 more ads than bills. Well, 3 more bills than magazines, that tells me that the stack of bills has to be bigger than the stack of magazines. I don't have to be exacting about this to make it 3 bigger. It just has to be a little bit bigger. Now, let me think about this for a second. We've got letters, bills, magazines, and ads, and they all should add up to, what, 31 pieces of mail? So if I understand that L, B, M, and A are actually the numbers of these things, then if I added them all together, shouldn't that end up being equal to the total number of letters that I got, or pieces of mail? So L plus B plus M plus A is going to be equal to 31. Next, that's one equation. I just need 3 more equations. So I go up and read it, and it says that there was 3 more bills than magazines. So if I knew how many magazines I got, since that's the smaller number, I could add 3 to it, and it would give me the number of bills. It also goes on to say that there was 5 more ads than bills, which means that that pile of ads has to be even bigger than the pile of bills. So, wait a minute, there was more ads, so the ads would be equal to the bills plus 5. Yeah, I want to write that down. So A for ads, that's the number of ads, is going to be equal to whatever that number is that's bills plus 5. Okay, well that's 3 equations out of the way. I just need one more equation. Let's look up there. It says something about, oh wait, the letters, the same number of letters as magazines. So the letters in magazines have to be the same amount. Well, I think that means that they need to be equal to each other. L is going to be equal to M. Okay, there's my 4 equations. Now, what we saw in the video about is a 10 equal to 2 5s is our substitution. We're going to be able to do some substitution here. So I'm going to take that big equation, the one that has all the variables in it, and typically we use the largest equation as kind of like the backbone to build off of. Because if we're going to substitute smaller equations into it, and the smaller equations might only have 1 or 2 of the variables, we'd like to have the equation that has the larger number of variables in it to be the backbone. Okay, so I'm just rewriting L plus B plus M plus A is equal to 31. Giving myself a little bit of room for substitution. Now, I know that B is the same as M plus 3. We're going to do the substitution, so if there's a B in the equation, and I know that B is the same as M plus 3, then I should be able to remove the B and just slide that M plus 3 down there. And I still have that equation. Okay, so if B is equal to M plus 3, it looks like M is becoming the dominant letter here. Wait a minute. A is in use in another equation, and it's the same as B plus 5, so I'm going to stick that B plus 5 down there. Now, at this point, we start to notice that there's an M and another M in the equation. It looks like M is becoming the dominant variable, and we see that, wait a minute, there's an L, and an L is the same as M, so I should be able to replace that L with an M. So I'm just going to do that. Now, M looks like it's almost it. If we could just get rid of that B in the B plus 5. Well, wait a minute. Earlier we had a B, and we replaced it with M plus 3. So I should, at this point, be able to replace any and all B's with M plus 3. So I'm just going to erase that B and slide the M plus 3 in there. Straighten it up a little bit. And now we have one equation with only one variable. So this is going to be solvable. That is, I've got an M, another M, and another M. That's 4 M's. I've got a 3, and the 5. That's going to be 11. And so if 4M plus 11 is equal to 31, we could subtract 11, and we'd have 4M is equal to 20. Oh, I can see the answer now. We divide by 4, and M is equal to 5. Now I know, since M is equal to 5, I can go back to one of those equations that has an M in it. Since L is the same as M, that means that L also has to be 5. Since M is equal to 5, and L is the same as M, then I could stick a 5 in place of that M. We're just substituting letters or numbers now for letters. Also, in that equation where I had B equals M plus 3, since I know M is 5, I can replace that M with a 5. So I'm just going to put a 5 in there. And so B is equal to 5 plus 3. So b is equal to 8. The last one says that a is equal to b plus 5. But now that I know that b is equal to 8, I should be able to replace the b with an 8. And a is going to be equal to 8 plus 5, which is 13. And of course, the 8 plus 5 plus 5 plus 13 is 31. We were able to solve the equation or equations using the method. In this problem, we had 4 variables. In the next problem, we're going to back off a little bit and not have 5 variables, but we're going to end up starting to stick some formulas in there. And that way, some of the equations will actually come from formulas. So look forward to seeing you in the next one.